Hi everyone, I'm Yu Chao Chen.
I'm Zhong Yo Wang.
I'm Zhi Chen, and we are
Team A.
Woo! Okay, first, this is our GPU design for EE533 Lab7. And first, we want to mention our design, data path design of our GPU. We have the data path graph here, and first is the instruction fetch stage. We choose the PC between normal PC jump target address and branch target address using the is branch or is jump signal from our mem stage. So it is a late branch design. And for our ID stage, the difference between this GPU design and the previous CPU design is that because we have the fuse multiple add instructions, so we need three source data to get into EX stage. So we have to add another register file here. So we got two register file in total in our ID stage. And also for our GPU design, we need a thread ID controller so that our system can work with one instruction and take out four pieces of data. Yeah, and this is our sign extend and control unit. Yes, and next is our EX stage. For our EX stage, we got our normal ALU to deal with normal sub or normal add instruction, and we also got a tensor unit design here in our EX stage to deal with the vector calculation that like vector add, vector sub, or fused of your operation. And this is the adder for our BTA and JTA. Yeah. And basically our mem stage and writeback stage are almost same as our previous CPU design. And so next we can look at our detailed tensor unit design.
Okay, so in the tensor unit design, so first, as you can see here, we do A times B, and then we just do the alignment, and later on we just do the addition and the subtraction, and later on we just lead in the zero detection.
Okay.
And finally we can get a 16-bit bit float.
Okay, so next let us show our local simulation on our model sim. So let's load the design again. Okay, so now we can look at our data memory. So here for our data memory address 2 is the, let's see here. Okay, for these three is our result of our normal add instruction. done by our normal ALU. So the vector sum is like this. Yeah, so the address 0 and address 1 is the input, and address 2 is the output. And these three are our vector sub result. Oh. Yeah, and next is our vector multiplication result here. And here is our vector fuse multiply and add instruction result, which do both multiplication and add by doing A times B plus C. And the last one here is ReLU, which makes the negative value into 0 and keep the positive value. And for the NetFPGA onboard simulation, unfortunately, we haven't done it yet because every time when our design loaded like this, and we load our IDS register interface like this, and we use our power on command to start our GPU and stop it, then read. We always get 0 value even when reading other memory locations. So we're still trying to deal with this problem, and we'll probably go to the TA the office hour tomorrow, and yeah, we super want to solve this problem. Yeah, but it is super difficult.
Very difficult.
But we really try hard for like 3 to 4 days with
this
almost zero sleeping.
Yeah, almost.
Yeah, we work super hard. Yeah, and I think that is. And thank you, everyone.
Yeah.
Yeah.
Bye.